Ladies and gentlemen, what I will introduce you to in this video will be something of colossal magnitudes. It will be generational mugging. Maybe you have never heard of this figure. To you, it might be some kind of old, boring looking white dude. What if I told you he was Russian? No, I'm just kidding. But yeah, he was Russian. But what if I told you he mugged this guy? This guy claims to be like the inventor of the, modern AI and blah, blah, blah. But this guy was actually the one who actually started everything. And it's not even generational mugging because they are more than 100 years apart. I don't know what the actual term is, but I think it's like century or centennial mugging, right? 100 years apart. It's like the self-proclaimed and the actual winner. You know what I'm saying? But yeah, okay, let's say it started. We're going to talk about Markov models. You've probably never heard of this thing before in your life, but you probably will look at this thing models and think, okay, well, he was developing some kind of chatbots in the 20th century. They had AI NSFW even in the 20th century. And that's not the case. They were very basic models, but they were manual. So that's the kind of crazy part about this, is that you kind of had to calculate things on your own if you wanted to generate them. Now you can make it on a computer, I think, but back in the day, that was not the reality. The way this would work is you give it some kind of input. We will discuss what kind of input. We will discuss how this works and everything like that. You give it some kind of input, and then it gives you some kind of prediction of what happens next. ChatGPT is a predictive model. It predicts the next token, as you know. So the Markov model will be similar. So, but before we get into that, we have to look at what some basic terms before we actually discuss like what we're talking about. In terms of Markov models. So first of all, a term you should know is called a state. It's like a variable that describes a distinct situation, condition, or mode. And so it could be in like a weather prediction model, Markov model for weather prediction. It could be something like sunny, rainy, cloudy, some kind of thing that describes the current situation. In a text prediction, I'm sure I cannot fully attest to this, but I think it's going to be something like, however, this is like a state, and then and just like any possible words, cat. Then you have a state space. It's just a collection of all possible states, right? So for example, a list of everything that the weather could be. It could be like sunny, rainy, cloudy, foggy, rainbowy, zesty, depressing, and then London, which is, let's be real, in a category of its own. Then you have something for words, which would be something like computer. Then you have some kind of other word, lamp, and then just like all the possible words that could be predicted by a text predictor. Then you have something called a process, which is just a way in which a state will evolve over time, like the weather over multiple days, right? In a summer, there are 90 days of summer, or 100 days of summer, more like it. Day one, the weather is sunny. Day two, the weather is cloudy. You get the idea, the way that things evolve. Then there's a deterministic model, which is a term describing a model whose processes describe exactly how a system will change over time and the outcomes are exact. So if you took like physics, you might know like something like this formula. This is just the force of gravity, acceleration due to gravity. This is time squared, and this is the distance. So it basically says at any point, no matter where you drop like a ball, the distance from that point to wherever it is, given like some kind of time period, is going to be the exact same. It doesn't matter if you throw it off of like where there's a lot of air resistance that could hold it back. It doesn't matter if you're like throwing off with a parachute, right? It will say that the distance is exactly the same, which is why I could be wrong sometimes, but you get the idea. Then there's something called a stochastic model, which basically says that there's probability, chance, and the outcomes are not always going to be the same. ChatGPT is stochastic, for example. Markov models are also stochastic, and that just means that if you input something into this model, you don't get the same result every single time. Like the same way if you make Stellar AI code something, you should sign up, by the way. You really should sign up. Link is in the description. If you like output something, then the output is not going to be the same. The code is going to be a little bit different, the kind of phrasing or whatever. Now we actually get to the Markov model part. There are two types of Markov models that were thought of by the Russian guy, which, by the way, I didn't tell you his name. His name was Andrei Andreevich Markov, right? That was his name. Like I spelled it horribly, but I think I spelled it right. Markov chains and hidden Markov models. So those are the two types. I've already talked about this, but there's the common use for Markov chains is predictive text, like T9 predictive text, just like on your phone. Or there are hidden Markov models which are used for speech recognition, actually, which is kind of cool. And each are stochastic models for predicting the future with what probabilities are known in the present. So what does that mean? There's a crucial thing that defines a Markov model is it has the Markov property. There's a lot of names with Markov. This guy really loved to name things after himself. I mean, I wouldn't blame him, but the past and the future are independent of each other provided that the present is known, which is called like a memoryless approach. So knowing what's presently happening is enough to predict the future. You don't need to know what happened yesterday. That's the assumption that this sort of system makes. So if it's sunny today, I can predict the weather for tomorrow, and I don't need to know that it was raining yesterday or that it was cloudy on Thursday last week or something like that, right? This manifests itself in this form. If you've coded before, you might know this, or if you've took like statistics classes like IB or AP stats or whatever, you certainly know this notation. So basically, what this says is the probability that some kind of state, whether it's sunny, rainy, or whatever, or whether it's a word like however, a word like and, a word like is going to be the future element, given that you know all of the things that have happened before from S1 to Si minus 1, which I is just like the iterator, like in a for loop. Given that you know all of that before, the probability of that is the exact same as the probability of the future element being some kind of state, given that you just know the last state, right? Just I minus 1. Like if I say today's rainy, then what's tomorrow? The chance of tomorrow being sunny, for example, like 0.4, which is 40%, is the exact same as me knowing that it was the weather today, the weather on Thursday last week. If I know all of this, it will still have the same chance of it being 40%. It just makes things calculating things much easier. Let's get into how this actually works. How a Markov model, the inner workings of how it actually, functions. You have something called an initial probability distribution and a transition matrix. So, and yeah, by the way, this little thing is cited below. I used like a proper PhD article or like a literature review. It's pretty cool, actually. You should go check it out. Let's just look at it. For example, so what is a transition probability matrix? It may look annoying to look at first. It may look like you're being taken back to college classes or high school classes. A transition probability matrix just defines, it's just like a multi-dimensional matrix, a 2D array, basically, just saying the probability of each and every state going from one point to another. So if there's sunny, you have to look at all of the chances of it going to other, and the chance of just being sunny tomorrow is also 0.25. And so that's just kind of the matrix that it is. This is element I, more like it. And these are the J ones, right? Aij just says the probability, which is like 0.25, right, for one of them. And the sum of all of them should always equal to 1, which just means like the chances, the percentages should always add up to 100%. And this is how you would visualize it. So if you have a state space, right, on a hot summer in Cordoba, Spain, I would really love to go. This basically just describes the chance of a day going from sunny to something else, right? And this chance of going from rainy to something else. And if you correctly noticed, this means sunny to sunny, the chance is 80%. Rainy to rainy, chance 55%. Sunny to rainy, 20%. Rainy to sunny, 45%. Which kind of makes sense. I just drew up these numbers on a whim, but if it's a hot summer, it's probably going to stay hot. And tomorrow there's a little chance of it being rainy. Then we have the initial probability distribution, which is the sum of these should also equal to 1. You don't have to like read all of this stuff. It's not that important, but basically what it says, if we don't know what today is, we need to have like a way to predict what today could be. Or just like if you start texting. Right. If you start telling your citing to pull up, you're gonna like open your phone and there's gonna be like some predictor text. It has to predict what's gonna be the first word that you're gonna say without knowing like any past kind of state. You could say that the first day on a hot summer in Cordoba, Spain would be 70% of chance of being sunny and a 30% chance of being rainy. And yeah, this is how it looks like. So if it's sunny today, it has a 70% chance of going back to being sunny the next day and a 30% chance of becoming rainy the next day. Conversely, if it's rainy today, 80% chance of being rain tomorrow and 20% chance of being sunny. This is not the Cordoba, Spain example. This is just a different example that they had, but it visualizes this pretty well. And that is pretty much the quintessential Markov chain. That finishes today's episode. If you liked it, please show that you liked it. Just like go comment something like, yo, good video, bro. Let's go. Go check out Stellar AI. You should really sign up. I'm making big changes. It will be awesome. And it will be nothing like you've seen before. So yeah, goodbye.